Integral and zero exponents. Objectives. Apply the laws involving positive integral exponents to zero and negative integral exponents. 2. Express the expression into non-zero and non-negative exponents. Let's review the following laws of exponent. First, that is product of a power. You're just going to add the exponents if we have here the same variable. Quotient of a power, divide the exponent of the numerator to the exponent of the denominator. Then we get the quotient. Power of a power, just multiply the exponent into another exponent. If we have here close and open parenthesis and we have here variable or a coefficient. Power of a product, multiply the exponent outside the quantity into the exponent inside the quantity or in product. Power of quotient, just distribute the exponent outside into the exponent of our quotient inside the quantity. Zero exponent, simplify a square divided by a square. So let's write that into expanded form, a times a divided by a times a. That is the factored form of these two variables. Then let's divide. Alright, we get the answer which is 1. This is not equivalent to 0 because if we cancel, meaning we divide the same number or the same variable. So we get 1. Applying the quotient of a power, we have here a square divided by a square. Let's subtract their exponents. 2 minus 2. So we have here a raised to 0. And based on our first example, a square divided by a square is equivalent to 1. And we have here the same given. Therefore, a raised to 0 is equivalent to 1. Because here we get 1. And on the other solution, we get a raised to 0. And this is equivalent to 1. Therefore, we can conclude that in zero exponent, that any variable or coefficient raised to 0 is equivalent to 1. Zero exponent. Any number to the 0 power is always 1, or x raised to 0 is equivalent to 1. Example, 4 raised to 0 is equivalent to 1. Another, 3 times 4 minus 1 raised to 0 is equivalent to 1. 5 squared times 5 raised to negative 2. So, applying the product of powers, you're going to add their exponents. So, we have here 5 raised to negative 2 or positive 2 plus negative 2. So, we get 5 raised to 0 because we subtract these two different sign numbers. And that is equivalent to 1. Another example, 12x squared. Since the zero exponent here is for x only and 12 is not included, therefore we write x raised to 0 into 1. Then copy 12. So we have here 12 times 1. The answer is 12 because only variable x is raised to 0 power. Next, 12x or quantity of 12x raised to 0. Since 12 and x are both included into the 0 power, we can distribute the 0. So we have here 12 raised to 0 and x raised to 0. That is 1 times 1 or equivalent to 1. Applying the law of power of a product, both 12 and x are raised to 0 power. Third, quantity of x raised to 0 plus 5 times the quantity of x plus 3 raised to 0. X here is equivalent to 1, then copy 5. Then both x and 3 are raised to 0, then we write that as 1. Then simplify 1 plus 5, that is 6. Multiply to 1, we get 6 for our final answer. Another example, 45a to the fourth power b squared divided by 5a to the fourth power b. Divide 45 and 5, we get 9. Then subtract the exponent of the numerator to the exponent of the denominator. Then also for b. So we have here 4 minus 4, we get 0. Then 2 minus 1 is imaginary 1. Then we can cancel a raised to 0 because this is already equivalent to 1. So we write only 9b because this is already equivalent to 1. Number 5, 10a to the 7th power times b squared divided by 5a to the 4th power b squared. Divide 10 and 5. So we get 2. Then subtract 7 and 4. Then 2 and 2 for b. So we have here 7 minus 4, 3. 2 minus 2, that is 0. Then copy 2. Then simplify since this is b raised to 0. This is equivalent to 1. So we get 2a cubed. Then 1 here is already imaginary. Next, 4m times the quantity of n minus p raised to the 0 power and then divided by 4m to the 0 power. Since both n and p are all equal to 0 or raised to 0, we write 1. Then m raised to 0, that is 1, and 4 is not included. Then we can cancel that 1 and 1 because 1 divided 1 is 1. So we get 4m divided by 4. And we have here 4 divided 4. We also get 1 for that. Then we get the final answer m. Integral exponent. An expression has an integral exponent if the exponent is either positive or negative exponents. Example, 3x, 5x raised to negative 2 plus 2, m raised to negative 8, x to the 4th power. So let's apply the quotient of a power. We have here a raised to m divided by a raised to n. That is a raised to m minus n. Just subtract their exponent. Examples, x to the 4th power divided by x squared. So we just subtract 4 and 2, we get x squared. So let's apply that in expanded form. Can we get the same answer? Let's try. So let's cancel out those pair with the denominator. So we have here remaining 2 pairs. Let's multiply that. X times x, we get square. Therefore, x to the 4th power divided by x squared, we get x squared also. And we have the same answer. Another, x squared divided by x to the 4th power. Subtract 2 and 4. As you can notice, the dividend here is less than the divisor. Or the minuend here is less than the subtrahend. So we can get here negative answer. And based on our objective, our final answer must be in positive exponent form. So let's apply another method. So let's get the expanded form of x squared and x to the 4th power. So let's cancel out those pair of numerator and denominator. Then we have here remaining 2 terms. Then let us write 1 above because we don't have remaining terms above. So copy x times x, and that is x squared. Therefore, we already get here positive exponent, but this is different from x raised to negative 2. As you can notice, x raised to negative 2 is the reciprocal form of 1 over x squared. But in this reciprocal form, the negative sign is already removed. Therefore, negative exponent means the reciprocal. Alright? Don't forget to remove the negative sign if you already written your answer into positive exponent. That is in reciprocal form. Another, a raised to m divided by a raised to n a raised to m minus n. The negative exponent sign in the exponent means the reciprocal. Thus, a raised to negative m is equal to 1 over a raised to n. So, the reciprocal of this first term is this 1. Don't forget to remove the negative sign if you already write your answer into reciprocal form. Another, what if our answer is in fraction form, but we get here negative sign? So, the reciprocal of this fraction is a raised to n over 1 or just simply a raised to n and remove the negative sign. Alright? Don't forget the meaning of negative exponent, that is reciprocal. So again, applying the quotient of a power, we have here 3x cubed y to the 6th power, x to the 5th power, y to the 4th power. Let's divide. So first, write down the variable y above because the highest number here is in the numerator, or the highest exponent here is in the numerator. So we can get positive exponent. And here, since we all know that the exponent of the numerator is less than the exponent of the denominator, we can get here negative exponent. So if you're not able to write the negative exponent, just write down here your variable and these two exponent, so you can get positive exponent. You can directly write the reciprocal of your answer so that you are not able to write down negative exponent here. So subtract their exponent, applying the quotient of a power. So we have here 3y, 6 minus 4, that is 2, x, 5 minus 3, that is 2. Just follow the position of the highest number of the exponent, or the highest value of the exponent. It's just the same here. Since 6 is above, so your variable y follows the position of the numerator. And then here, the highest value of the exponent is in the denominator. So you write the variable in the denominator so you can get positive exponent. So that is already in final answer. Number 4. Divide 28 and 7. Then subtract these two exponents of B and exponents of C. 28 divided by 7, we get 4. A to the 5th divided by a to the 5th, that is 0. Or B raised to 6 minus 4, we have here 2. Then follow the position of the C here below because the greatest exponent here, if you compare C and C cubed, the position is in the denominator. So write down here in the denominator the C and your answer, which is already in positive. Because if you write here C raised to negative 2, you're going to move that below to make it positive. But you can directly write your answer into the opposite position of the variable so that your answer is already in positive exponent. Then, cancelled out a raised to 0, that is equivalent to 1. And here is our final answer. Another. So we have here a square, 8 square raised to negative 1. So you can apply the power of a power by multiplying 2 into negative 1. We get negative 2. And that will be the new exponent of 8. Since this is negative, multiply 8 by itself twice. 8 times 8, that is 64. Since this is negative, the reciprocal of 64 is 1 over 64ths. Another, 2x times 5x cubed y. Just multiply 2 and 5, we get 10. X times x cubed, add 3 and 1, we get 4. Since y here doesn't have a pair here, just copy y. So that is final answer. Remember, zero exponent, any number raised to zero power is always 1. Wherein x raised to 0 is equivalent to 1. In negative exponent, the negative exponent sign in the exponent means the reciprocal. Thus, we write a raised to negative n equals 1 over a raised to n, or 1 over a raised to negative n, or equivalent to a raised to n. In integral exponent, an expression has an integral exponent if the exponent is either positive or negative exponent. And here are some laws of exponent you can use in simplifying integral exponents, such as product of a power, quotient of a power, power of a power, power of a product, and power of a quotient. And thank you for listening. And remember, you only fail when you stop trying, by Albert Einstein. Goodbye.